C++ Programming from Problem Analysis to Program Design, Chapter 9, Arrays and Strings. In this chapter, you will learn about arrays, how to explore and declare and manipulate data into arrays, learn about array index out of bounds, and become familiar with the restrictions on array processing, discover how to pass an array as a parameter to a function. Here also, we are going to learn how to search an array, learn about C strings, examine the use of string function to process C strings, discover how to input data into and output data from a C string, learn about parallel arrays, discover how to manipulate the data into a two-dimensional array, and learn about multidimensional array as well. From CS 126-8, we already learned about data type. A data type is called a simple if variables of that type can only store one value at a time. But this time, we're going to discuss all about array, and array is already considered as a structured data type. A structured data type is one in which each data item is a collection of other data items. When you say array, array is a collection of a fixed number of components wherein all the components have the same data type, meaning this is a homogeneous element. First discussion of an array is what we call one-dimensional array. So when we say one-dimensional array, the components are arranged in a list of 4. So this will be the syntax if we're going to declare a one-dimensional array. First is the data type. Data type are those float, integer, char, or double. Array name, so we're going to assign the array name, followed by a subscript or a bracket. Within a bracket is the integer expression or the size of the array. Integer expression must be evaluated to a positive integer value. Let's say, for example, we have the declaration int list subscript 10. This means that we have an array named list with an array size of 10, and all elements will be declared within the list should be an integer values. So if this is already the illustration of the array named list, the first position or the starting position or the address should start at 0 and ends with 9. So how are we going to identify the last position of the array? You should only subtract or minus the array size to 1, and that's the last address of the array. So from the previous declaration of list, which is int list subscript 10, how are we going to assign values, or how are we going to access the array components within the list? So let's say, for example, we have list subscript 5 equals 34. This means that we're going to assign value 34 to the 5th position of the array named list. So if you're going to take a look at the illustration, we already write down 34 into the address of subscript 5 or the 5th position of the array named list. Let's have more examples of how are we going to access array components in the array named list. So again, another example is list subscript 3 equals 10. This means that we're going to assign value 10 to the 3rd position of array named list. So we're going to write down 10 on list subscript 3. Then we have list subscript 6 equals 35. So again, we're going to assign value 35 or element 35 to the address of list, which is in position 6. Next, we can also use this as an operation. For example, if we want list subscript 5 to be assigned with a value, adding the value we have in list subscript 3 and list subscript 6. So we're going to add whatever the elements in list subscript 3 to list subscript 6. In this example, the value we assign, or the component or the elements we assign in list subscript 3 is 10, and the value assigned for list subscript 6 is 35. when we add that values, that will be the assigned values of list subscript 5. So if you're going to take a look at the illustration again, in list subscript 5, or the fifth position for the array name list, we assign 45. And that's actually the sum of the values of subscript 3 and subscript 6. You can also declare arrays with const or name constant. For example, const int array size equals 10. That means we're going to make use of the array size variable to the declaration of the array named list. So we have int list subscript array underscore size. It means that the list contains a size of 10. But take note, if we're going to make use of const, that's already a constant value and we cannot change it during the execution of the program or the code. Now, take note of this. When you declare an array, the size must be known. For example, you cannot do the following. So if this is your code, we cannot actually do this. List or line number 5 is not allowed. So we need to identify already the size of the array on the declaration statement, not within the execution statement or executable statement. To process a one-dimensional array, these are some basic operations we need to perform. First, we need to have the initialization and the input data, the output data that will store it into an array. And for example, if we want to find the largest or the smallest element, so we need to have also a basic operation for that. So take note that each operation requires ability to step through the elements of the array from the first position, which is address 0, up to the last position, which is size minus 1. And we can only perform the processing of one-dimensional array if we're going to accomplish it by a looping statement. So let's consider the declaration of the following. Int list subscript 100, then we have int I. The first line is the declaration of the array that contains 100 elements. So if it's 100 elements, the first position must be 0, and the last position is the size minus 1, which is equivalent to 99. Then the second declaration, int I will be the assignment of the looping we're going to use for the counter, starting at the first position, which is position 0, and for the last position, which is 99. Now, if we're going to make use of the for loop to access all the entire array elements, we're going to make use of the for statement or the for syntax, followed by the parenthesis, and the parenthesis contains three expressions. The first expression is the initialization, which is we started it with the first position of the array, which is 0. And then we're going to have the second expression that is conditional. It means that we need to stop the execution of the loop until we reach the last size of the element or the last size of the array, which is 99. So that's why we have I less than 100. And each element is accessed and increased by 1. So that's why we have I++. So after 0, we need to move to the next array elements, which is at position 1, next array elements at position 2, and so on and so forth. Then if the second expression, which is I less than 100, is true, we process the list. So for example, for I is equals to 0, I less than 100, I++, and if we want to input or ask the user to input the values from the first position up to the last position, we use the syntax cin, and then the greater than sign, and then the name of the array, which is list. And if we want to access the entire element, subscript should contain I. Example 9-3 are examples on how are we going to process one-dimensional array. For example, if we want to initialize the entire array to 0, so we're going to make use of the for loop, started it with index 0 or position 0, since the size of the array is 10. So we're going to have an expression or the second expression, index less than 10. Then since the index is increasing by 1, so we have index plus plus. Then we have sales index equals 0.0. This means that we're going to assign the entire elements or components of array sales initially to 0. The other example is feeding data into an array. This means we're not assigning it into 0 or the entire value to 0. Instead, we are asking the user or prompting the user to input the values from the array named sales. So in this case, we're going to make use of cin and then sales. And then if we want to ask the user to input the entire values from the elements of sales, so we use subscript index. And if we want to already print the values within the array list, so instead of using cin, we use cout. And then the name of the array and then the index that we are going to make use of to access the list of array. How are we going to identify if the array index is out of bounds? Let's say, for example, if we have the statements below, double num subscript 10, int I, so this means that we have an array named num, and it has an array size of 10, and the declaration of the entire components is double, so this means that all the elements contains values with fractional components. So take note that the component num subscript I is valid if I is from 0, starting position of the address is 0, up to the last position, which is size minus 1, which is 10. So these are the valid components of num subscript I. 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So this means that the index is not out of bound. The index of an array is in bounds if it's greater than or equals to 0 or less than or equals to the array size minus 1. So let's say, for example, if my component will be assigned to num subscript 6, position 6 is within the bound. But if it's not within the bound, that's already considered as out of bound. So let's say, for example, if I have num subscript 15, num subscript 15 is not anymore within the bound. It's already out of bound. Why? Because 15 is not valid, because if your declaration is 10, the valid address or position of num is only from 0 to 9. So in C++, take note that there is no guard against indices that are out of bounds. If we're going to create an array in C++, array can also be initialized during declaration. So in this case, it is not necessary to specify the size of the array, since the size is determined by the number of initial values in the braces. So let's say, for example, double sales, we only have subscript here, we do not have the size of the array, equals, and then followed by the curly braces. Within the curly braces are the values 12.25, 32.50, 16.90, 23, and 45.68. So again, if we initialize values or if we initialize components during the declaration, size is an optional. You may use double size and then count the number of the initial values within the curly braces. So in this case, we have 1, 2, 3, 4, 5. So you may use double sales subscript 5, or since we already declared the values, okay, you just use braces instead. We can also do partial initialization of arrays during declaration. For example, we have statement int list subscript 10 equals curly braces 0. So this means that we are already initializing the values or the component of array named list with a value of 0. So again, it declares to be an array of 10 components and initializes all the components to 0. If we have statement int list subscript 10 equals curly braces 8, 5, 12, it declares list to be an array of 10 or a size of 10, but the components are just 8, 5, and 12. So how are we going to assign those? 8 will be assigned to the first position, 5 is on the second position, and 12 is on the third position. So what's the first position of the array named list? That's the first position is 0. So 8 will be assigned to list subscript 0. 5 will assign to list subscript 1. 12 will be assigned to list subscript 2. So what should be the values, or what must be the values if we're going to pertaining to position 4 up to position 9? So take note that if we have only partial initialization, the rest of the position will be initialized to 0. Another example, if we have statement int list subscript only without the size of the array equals curly braces 5, 6, and 3. So list declares to be an array of 3 components and initializes 5 to first position, which is list subscript 0, 6 in list subscript 1, 3 in list subscript 2. Int list subscript 25 equals 4, 7. So if we included the size of the array within the bracket or within the straight bracket, so that means that 4 will be assigned to the first position, which is list subscript 0, 7 will be assigned to list subscript 1, and all the other components will then be initialized to 0. Here are some restrictions on array processing. So let's consider the following statement. Int my list subscript 5 equals 0, 4, 8, 12, 16. And we have another declaration of an array without initialization, which is int your list subscript 5. Take note that C++ does not allow aggregate operation on an array. So let's say, for example, if we have a value of elements to my list and you want to copy all the values or the elements from my list to your list, this is illegal. Your list is equals to my list. So what should be the solution if we want to copy the value of my list to your list? Solution should be, you need to use a looping statement. An example of a looping statement is for loop. And then you're going to access the entire elements of your list by copying from the first position to the last position of my list. Example, for int index is equals to 0, index less than 5, index plus plus. So within that particular loop, we have a statement, your list index is equals to my list index. So if we're going to make use of my list position 0, my list position 0 contains a value of 0. So 0 should be assigned also to your list position 0. So that's when we want to copy the value of the initialization of my list to your list. These are also an example of illegal use of array processing. So let's say, for example, if you want to assign value to your list, C in your list is illegal because your list here is not a structured variable. Instead, this is just a simple variable. To make it an array, you must use the subscript. So the solution is C in your list, then subscript, and then the index. So the following statements are also legal but do not give the desired result. Since we use your list, okay, and if we use the your list and my list without the subscript, that is syntactically correct but logically incorrect. So again, if you're going to make use of my list and my list is an array as well as your list, you should use the index or the bracket.